Hello everyone, it's July 18th. Wow, tomorrow we will get our second cat. Nervous and excited at the same time. I've been watching a lot of Jackson Galaxy, trying to learn how to introduce an adult cat to another adult cat. So our cat's 2 years old, a bit over 2 years old. The cat we want to adopt seemed to be a little bit over 1 year old. So it's adult to adult. We're going to do hopefully everything as much to the book as possible, and I'm ready to have this process take months, because I've read like sometimes it does take months, sometimes even after months things don't work out. So we're gonna have the cat take their pace, right? Don't rush, and hopefully everything will end up well. Alright, but first things first, we have finally an easy one. Pascal triangle. So we can do 2 today, hopefully. Okay, is it just to build the Pascal triangle? 30 rows. Okay, what do we return? A list of lists. Okay. No, we can just iterate through it. Yeah. Let's do this. I must have done this in a very, very early time. Alright, so rest equals this. Actually, first 2, we need to 1, 1, 1, right? If num rows 2, 3, 4, 5, num rows is smaller or equal to 2, return res. Well, actually no. When I say if num rows is equal to 1, return 1. If num rows is equal to 2, return 1 or 1. Else, okay, for I in range from 3, the num rows plus 1. Alright. Press $pen, yes, and for J in range 1 to land, the rest. Ooh. Actually, I don't want this. Temp equals this. Okay. Append res minus 1, J plus res minus 1, J minus 1. And then temp, append 1, and rest dot append temp, and now return res. That shall suffice. So 5 give us this. Oh, I actually keep going. 6 shall give us 1, 5, 10, 10, 5. 5, 1. Let's do one more. 7. 1, 6, 15, 20, 15, 6, 1. Okay. Num rows. Huh? Oh, that's 2021. June the 21st, about a year ago. So yeah, there's nothing to say about this. All right, done with this. Minimum lines to represent a line chart. Oh, I just refreshed it. We're given a 2D integer array, stock prices, where stock prices I equals days and price. Okay, indicates the price of the stock on date I is price I. Line chart is created from the array by plotting the points on an xy plane where the x-axis is representing the day and the y-axis is representing the price. Connecting the adjacent return the minimum number of lines needed to represent the line chart. So in this case, we have 1, 7, 2, 6, 3, 5. And that's 1 line, 2 lines, 3 lines. So basically, we're trying to see how many lines that we need. It just as we go through, we want to see their slope, right? If the slope consecutive pairs, if the slope are the same, right? So 1, 2, well, 1, 2, we're going to always have a line. And then the third one, so 2, 3. If 2, 3, the slope is same as 1, 2, then it's still one line. If it's different, then that's a different line, and we reset. And keep going, and then we reset. Yeah, I think that should be it. Unless there's other tricks. Days are distinct, okay? Are the days always increasing? No, look at this. It starts with 3, 4, so we have to sort based on the first. Right, we sort based on the first. The first is the day. Okay. B. Okay, so we're gonna first sort. That should be fine because when we sort, the default is always sort based on the first. So we sort it. Then for what? I have to do the slope. Alright, S. Take the first two. Well, what's the minimum number? Length could be 1. So if it's 1, what if it's 1? Is that 0? Oh, yeah, it is 0. So n equals land stock prices. N is equal to 1, turn 0 if n is equal to 2, return 1, right? Okay, now it's sorted, and I'll say S is equal to the price is the second one. Okay, so we say stock prices 1, 1, a minus stock prices 0, 1. So that is, oh, shoot. Alright, so we can cheat here. I see what happens. Hold on, maybe we can use maybe math dot is close. Alright, I'm gonna try math dot is close, see if it works. If it doesn't work, we have to go, man, we're gonna go GCD this thing. I'll probably use fraction. Let's use fraction. Yeah, well, you in Python, so we can use fraction. I don't know how to use it, so I have to take a look. Fractions, rational numbers. So we'll say the fraction. Okay. I want to try. We just want to pair equal, right? So we say from fractions import fraction. Okay, so we say a equals fraction. I don't know, 13, 16, 10. That's a good one. B equals fraction 32 and 20. A equals B. That's true. Okay. That's all I need to know. That's all I need to know. So we say from fractions import fraction. So we're gonna say equals fraction. This. Oh, it's this. Right, and then the stock prices 1, 0 minus stock prices 0, 0, right? Okay, so that's our initial slope. And now we say for I in range 0, 1, 2 to n, and then we say rest is equal to 1. And we say, what do we say? Temp equal to fraction. Stock prices I 1 minus stock prices I minus 1 1, right? And stock prices I 0 minus stock prices I minus 1 0, right? So that's a temp. We just say if temp is not equal to s, res plus equal 1 and s equals temp. And now we go through the whole thing and then return res. Alright. Let's see. We check those so we don't have to redo that. This is a good one. This is a good one. Prices. Minimum. Okay. I don't know. Just throw something at it. Fraction is not defined. Oh, it didn't import fraction. Surprise. I don't know, maybe they expect you to ooh. Took so long. I mean, if it's contest, I'm happy with this, but yeah, maybe they expect you to use, I don't know, but is it going to be faster to use GCD to handle this? We can write a GCD version, honestly. Sort, and then compute pairwise consecutive pair. Compute slope between consecutive pairs. If the slope is the same as previous, we are on the same line. Otherwise, create a new line. O(n) log n, because we sort at the beginning. Okay, so we're going to go GCD and then divide. So avoid. I don't know. Honestly, I don't really think. Math import GCD. I really don't think GCD will make this one any faster. But nah, I never know. Try GCD. Try using GCD instead of fraction. So if G equals GCD, basically, oh man, it's Y, dx dy. Okay. Actually, it's dy dx. Dx, and G equals GCD, dy dx, and then S will equal to dy divided by G, dx divided by G. Okay. So here, same thing. Alright, so instead of doing this, let's say dy dx equals this, and we say G equals GCD, dy dx, and we say if temp is equal to dy, g dx, g f this, and this. Okay, let's try number 2. All right. See if this one, if it's any faster. If not, that means the time consuming, it's much faster. So GCD is much faster. Still O(n) log n, but but it's much faster. So this shows that fraction has a huge overhead. And then GCD is better. Alright, let's see the description. GCD slope. Hidden test cases. What happened? Yo, this is smart. Oh, they use, oh my god. That's why people don't like it. You can't, floating point. You guys never get bitten by floating point before, have you? I have. So, floating point, the first thing in my mind is this fraction. That's why I know it, because I got bitten before. But honestly, GCD is easier. But this is actually good. Now, how are you gonna the complicated? You know what? Yeah, this might actually even be faster, right? You get the previous dy dx. You just say previous dy dx equals current dy, so you just do multiplication. Oh yeah, I actually like this idea. This might actually be faster because we don't have to do GCD at all. I didn't realize. Alright. This comment inspired me to try yet another way. No need to fraction or GCD because we can do what's it called? Cross multiplication. Alright, so this is the same, this is the same, we get this, and no, GCD. What do you call it? We call it S. This is my S, right? It's fine. This is S. And then we get, this is a new. I don't even have to say S. I just call it dy dx. And we just call it dy underscore, dx underscore, right? And now this, we just say if we want dy over dx equals dy underscore over, so it's dy times dx underscore is not equal to dy underscore times dx. Then rest, and then dy dx equals dy underscore dx underscore. Alright, let's try number 3. Oh, I forgot to do this. Yep. Like seriously, I think this one might be the fastest one. Let's try this. No GCD. Yeah. This is the one. This is the one. Let's see. Okay, it's alright. It's alright. GCD is pretty good. Yeah, I like this one. Okay. I don't think you need to hate on this question. It's a good question. It's not difficult, but it does like just test this tiny thing of how do you know how to deal with a floating point, right? All right, we have exhausted all the easy ones for this one. The next one is going to be difficult. Sum of total. We're not going to look at it. I'm going to torture us tomorrow. All right, that will be it for today.